Hello, I welcome you all. The problem reads, and we are reading the second problem. We already solved the first problem. The pendulum bob B has a mass of m and is released from rest when theta is equal to 0 degrees. Determine the tension in the string BC immediately afterwards, and also at the instant the bob reaches the arbitrary position theta. So we are solving this problem. Okay, we already solved this one. Okay, so we are going with the the second one. Both problems are coming from the Engineering Mechanics and Dynamics, our 14th edition by R.C. Hibbeler. To start with, let's draw the free body diagram, and I'll use this one here. Okay. There we go. We have the weight. Then this weight, you will have components. One component will be along this direction that we are calling the n-axis. And the other one will be in that direction that we are calling the t-axis. So let's do a section. Let's do a section of this. We do a section. We are going to have some tension force in there. We'll have some tension force in there. I'm going to have tension force like so. Like so. Alright, and we do have these axes here. We have this axis, which is the n-axis. And then we have this axis, which is the t-axis. All right. So this is the t-axis. Let me just label them. So this is t. This is t, and this is n. And then this one is the tension. This is t. This is t. Right, let's check the angle. So if we are to draw this horizontal line like this angle here is theta. This one becomes 90 minus theta. Therefore, this one is theta also. Okay. So having established that, we can go ahead and label this one is our theta. This is W. And therefore this just becomes W cos theta, and then this one just becomes W sine theta. Okay, so like we said, we are on case 2. We already solved case 2. We already solved the first case. This one is a 13-64. A 13-64. Right. So what do we have? Let's write down the equations of motion, and our idea is to come up with an equation for t, which will be a function of theta. Right. And all we have is just m. Everything else are just t. We don't have real numbers. We have one case where we have theta equal to 0. The rest we should be able to determine t at any arbitrary position theta. So let's start with the t-axis so that we are able to find our velocity of speed, which we later on are going to use to find t. So let's also indicate kinetic diagram. So we have our acceleration in that direction, that axis, and then there in that direction, in that axis. This is our MAT, and this is our MAN. So let's start with the t. So say summation of forces in the t direction going up, down, being our reference, and this is just equal to MAT. Alright, so what do we have in this direction? We have W cos theta is just going to be equal to MAT, and therefore our AT is just equal to W cos theta divided by M. So once we have this, let's now find the velocity. Let's now find the velocity from theta equal to 0 to an arbitrary position theta, right? So I'm going to use this equation. Remember this kinematic equation. A ds is just equal to V dv. Remember this? A ds is equal to V dv. Okay. But when you look at our acceleration, it is in terms of theta. So we'll have to rewrite our ds so that it's also in terms of theta. So we know that given an angle like this arc distance like so, s, and this is r, we know that s is just equal to r theta, and so is ds will be equal to r d theta, right? So with this relation, we can say our ds is just equal to r d theta, right? So with that in mind, we can replace this here, and once we do so, then we'll have, I want to replace a with at there, and then we'll have r d theta like so. This is just equal to v dv. So let's integrate this. Okay, and here our boundary condition for theta is theta equal to 0, then to theta, an arbitrary value. Then at this point here, our initial velocity is 0 because this is momentarily at rest at B, and then later on it's released. So V naught is equal to 0 to V. So replacing those the acceleration in there, will have W over M cos theta, and then we'll have R. So let me just put R in front here. I put R like so, and then I have cos theta. Okay, and then d theta, this is just equal to 0 to V, then V dv. So integrating this, we'll have W over M R sine theta, and this is just equal to V squared divided by 2. And our V squared will just be equal to 2 W divided by M R sine theta. So this is the value of our W squared, and we'll leave it like this because we are going to use it later on when we are apply another equation of motion in the n-axis. So let's do so. So we'll say summation of forces in the n is just equal to MAN, and then going in that direction being our reference positive, where our AN is just equal to V squared divided by rho. Okay, and we know to say our rho here is just equal to R. Okay, so let's write down this. So this just becomes this one becomes T minus W sine theta, and this is just equal to M V squared divided by R. Okay, and then our T therefore is just equal to M V squared divided by R plus W sine theta, and we know that our V squared is just equal to 2W divided by M R sine theta. Remember, this is what we found. So this we can replace it. We replace it here. Okay. And once we do so, then we are going to have our T, which will just be equal to Of course, m and m will cancel each other out. All right, let me just write everything. So we have m, and then later on divided by r. Okay, and then we have this b, which is just 2w divided by m r sine theta, then plus w sine theta, right? So we can cancel out r there, and r cancel out m and m. And then later on we just remain with 2w plus w, so therefore our t is just going to be equal to 3w sine theta. Okay, 3w sine theta. All right, so we have been asked in the first case to find determine the tension, determine the tension in BC immediately afterwards. So the tension when theta is equal to 0 degrees will just be equal to 0. Okay, to just equal to 0. Okay, and not been told any units, just be equal to 0. Okay, either 0 pounds, okay, 0 so I'll just say 0, then here I'll say units of force. Okay, so these units can be anything, can either be pounds, can either be newtons or whatever. Then of course we know to say at any arbitrary value of theta, our equation is just 3w sine theta. And we know that our maximum theta, our maximum t rather, our maximum T max, we have not been asked to find this. T max will take place at theta equal to 90 degrees, right? Know that, right? And this will just be equal to 3w. You can take the first derivative of this, equate it to 0, and then find theta. To find that theta is equal to 90. That's where we have the maximum. Alright, I think this is really about it, and I hope this particular video was helpful, and if it was, let me just outline the solutions. So we have all these solutions like so. So if the video was helpful, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and see you in my next screencast.